Hi, I'm Andy, and this is my lesson on instance and class variables in Java. In this lesson, I'll show you how to add both instance variables and class variables, which are also called static variables, to a class. I'll also show you the difference between the keywords public and private. Let's get started. Let's continue designing the rectangle class from my previous lesson. As mentioned in that lesson, the class's instance variables will be defined here at the top. Instance variables are all the bits of data needed to fully describe the rectangle object at the present moment. This full description of an object is called the state of the object. I like to think of instance variables as the values that distinguish one rectangle object from another. So what values are needed to define the state of a rectangle object? Well, every rectangle object has both a length and a width, so those are two of our instance variables. To make instance variables, we start with the keyword private. I'll talk more about why that is later in this lesson. Then you put the data type and the name of the instance variable. I want to allow the length and the width to be decimal values, so we'll make the data type double for both. And that's it. Notice we don't want to initialize these variables to a value with an assignment operator here. That's because we don't know what they should be until a rectangle object is actually being made. We just want to declare the variables in this section. Let's make another instance variable, this one an integer called ID. A rectangle object's ID will be used to identify it when our program is managing multiple rectangles at once. Depending on how this class is going to be used, we might want to add some more instance variables. For example, if this is for a drawing program, we might add variables like color and position, as well as others. For simplicity, let's not worry about that and just stick with these three instance variables. There's other values that you may think would be useful as instance variables, like area and perimeter. We do not want to make those instance variables. Those values can be easily calculated from the length and the width. They are not independent values that need to be tracked separately. Now let's discuss this keyword private right here. That is called the access modifier. The access modifier is used to limit the code that can access the variable's value, meaning view it or change it. By putting private, we are saying that only code within this class can access these variables. We're doing that because we, the class designer, want to strictly control how and when the values of instance variables change. We also don't want outside code to even view these values. If we allowed that, our code and that outside code might become coupled, meaning if we ever wanted to change our rectangle class by either renaming or removing these variables, we'd have to worry about breaking all the outside code that uses the class. Basically, by putting private here, we are completely hiding these variables from outside code that is using our class. That gives us the freedom to change them any way we want in the future. Hiding your instance variables from outside code using the private access modifier is called data encapsulation. As you mature as a Java programmer, you may find there are times when you will want to use a different access modifier, like protected or public, which allow greater access to your variables. But as a new Java programmer, I highly encourage you to adhere to strict data encapsulation practices by always using private for your instance variables. Let me show you how this all works. Let's make a rectangle object in our main method. Now remember, the main method is in the main class. Also remember, to make an object of any class, you use the keyword new followed by the name of the class. I'll discuss this line of code in detail in the next lesson. For now, you just need to know that this line has created a rectangle object, and rect is the reference to that object. To try to access an object's instance variables, we use the dot operator, like this. This line of code is saying, go to the object referenced by rect and set its length variable to 7.2. Let's see what happens when we run this code. We got an error because we're trying to access a private instance variable with code that's in a different class, main in our case. Now let's see what happens if we change the instance variables to public. Notice no error. When an instance variable has a public access modifier, any code anywhere can view and modify its value. Since we don't want to allow this, we want our object's data to be encapsulated, we'll change the modifier back to private. Now let's look at another type of variable you can add to your classes. Suppose we want to have a default size for our rectangle, in case the user of our class does not specify a length and a width. That value is not an instance variable, because all rectangle objects will share the same default size. There's only one default size for all rectangle objects. Values that are shared by all objects of a class are called class variables. Some prefer to call them static variables because to make them, you use the keyword static. Okay, there's a lot going on this line of code, so let's go over what each of these keywords does. First, you see the word final here. That's because a rectangle's default size won't change while the program executes. Default size is actually a constant, not a variable. Notice we always use the all caps convention for Java constants. The double here is simply the data type for this constant. As discussed earlier, the static keyword indicates that this constant pertains to the whole class. Different rectangle objects will not have their own values for this constant. I use public here instead of private because I decided I wanted to allow outside code to view this value if it needs to. This isn't very risky because default size's value is final, so it can't be changed, only viewed. Of course, if it turns out that outside code does not need to ever view this value, I would further encapsulate my data by changing public to private. So that's a static constant. Now we'll make a static variable. Just like a static constant, a static variable is stored in one place and shared by all objects of that class. The static variable we want to make is called num_rectangles. Its job is to keep track of how many rectangles have been made by the program. In a later lesson, you'll see how we use that information to assign a unique ID to every rectangle object. Num_rectangles will only be used internally within this class, and I definitely don't want to allow any outside code to modify it, so we'll label it private. We'll also give it an initial value of 0 since when this code executes, no rectangles have been made yet. Now let's try to print the values of both default size and num_rectangles in our main class. To access a static variable or constant, we use the dot operator again. However, since these belong to the whole class, not a particular object, we put the name of the class in front of the dot, like this. As expected, we got an error on the line of code that is trying to access the private variable. whereas accessing the public constant worked just fine. Let's comment out the bad line of code and try to run it again. Good, so that worked. So that's how you create static variables and constants in a class and how you access them in other parts of your program. And that wraps up this lesson on instance and class variables in Java. I'm Andy. Thanks for watching and coding with me today.